One of the things we're going to want to do with angles is use them to measure positions between things. But there are a couple things that make that kind of hard to do. Let me show you what the problems are just by way of an example. So here are a couple points that I've labeled here and there. And the question I want to ask is, what is the angle from here to there? Well, that question doesn't even really make sense. You can't measure angles because we don't know where we're measuring from. So to measure angles, that's the first thing you need to do is decide where you're going to measure from. And there is a standard choice on where you're going to measure from and also what direction you're going to measure. So these choices together go under the name standard position. So unless we have reason not to put our angles in standard position, we'll always put our angles in standard position. And here's what standard position is. So first, draw a set of coordinate axes. And when you draw your coordinate axes, the vertex of the angle, that is the point of the angle, must be at the origin. So that's the first part of standard position. So notice I've put the origin. So we're going to have to draw an angle so that the origin of this coordinate system is the point of the angle, the vertex of the angle. Now the second part of standard position is where to measure from. And we're always going to measure our angles from the positive horizontal axis. So that is this blue segment here. So we will always start measuring our angles from there. And now we have to decide which way are we going to measure angles, clockwise or counterclockwise. And the answer is, in mathematical contexts, always counterclockwise. So always measure counterclockwise. Well, almost always, as you'll see. So counterclockwise will be the positive direction for our angles. Okay, so we have our starting side, which is always the positive horizontal axis. Our ending side is from the origin out to the point we're going to, and we will measure our angle counterclockwise that way. So that will be a positive angle. It looks like it's about 45 degrees, so this would be about positive 45 degrees, or pi over 4 radians. Now, one tricky thing about working with angles is knowing where this ending side is. That's not enough to know what angle you're talking about, because there's more than one way to get up to this, this ending side. So if you look at it, when I was drawing this blue arc to indicate this angle, I didn't really need to stop at this side. I could have kept going like this. So I could go all the way around and then up to that angle again. Now that's a different angle since it represents a different amount of rotation, but it ends in the same place. So one tricky thing about angles is angles that are different sizes can actually end in the same place. The name for angles that end in the same place are coterminal. So this blue angle and the yellow angle actually are coterminal. Let's figure out what this coterminal yellow angle is. So we said that the blue one was about 45 degrees, or pi over 4 radians. How could we produce the yellow angle from this initial pi over 4 radians? Well, if you compare the blue to the yellow, we get the yellow angle by first doing the blue angle and then going around a complete rotation. But we know that in radians, a complete rotation is 2 pi. So we can take our pi over 4 and just add 2 pi to it. And that will give us the coterminal angle, the yellow one. So pi over 4 plus 2 pi, that's pi over 4 plus, let's see, 2 pi is 8 pi over 4. So that's going to be 9 pi over 4 radians. Okay. So every ending position for an angle actually has infinitely many coterminal angles that end at that same spot. You could go around once or twice or 3 times, as many times as you want. So there are lots of angles that all end in the same spot. In fact, you could get to this spot not just by going counterclockwise, but also by going clockwise. So let me redraw that angle. So we had a pi over 4 radian angle like this. But we could also get to the same side by, instead of going counterclockwise, we could go clockwise like this. And that would give us another coterminal angle. Let's see what this green angle would be. Well, you can see we could produce this green angle by doing the blue angle, but then going the opposite direction a full turn. Okay, so we could start with our pi over 4. Well, if going counterclockwise is positive 2 pi, that means going clockwise should be negative 2 pi. So we should subtract 2 pi radians. So that's pi over 4 minus 2 pi, which is 8 pi over 4. And this is negative 7 pi over 4. And this is in radians. So it turns out that negative angles make perfect sense if you have an angle in standard position. A negative angle just means that you went clockwise instead of counterclockwise. Okay. So just like you could go counterclockwise again and again to get more and more coterminal positive angles, you could go counterclockwise again and again to get lots of coterminal negative angles. All right, for one more example of this, let's list a positive and a negative angle that are coterminal with 2 pi over 3 radians. I guess maybe the first thing we should do is get some idea of what this angle 2 pi over 3 actually looks like. So pi over 3 is 60 degrees. 2 pi over 3 is twice that, so that's 120 degrees. And it's about here. So there's 2 pi over 3. Okay, we know we can generate coterminal angles by adding 2 pi. So that would be going around another. So let's take our 2 pi over 3 radians and add 2 pi to it. So 2 pi is the same thing as 6 pi over 3. And now we can add these up. We get 8 pi over 3. So the red plus the blue angle is 8 pi over 3. To get a negative coterminal angle, we could just go the opposite direction. So instead of going counterclockwise, go clockwise. And that's 2 pi over 3 minus 2 pi. So that's 2 pi over 3 minus 6 pi over 3. And 2 minus 6, that's negative 4. So negative 4 pi over 3. So that green coterminal angle is negative 4 pi over 3. So always when you measure an angle, unless you have some reason not to, put it in standard position. And in standard position, positive angles go counterclockwise and negative angles go clockwise.